Assalamualaikum. We are from Group C2. Will be presented about our mini project. First, before we start, I will introduce myself. I'm Muhammad Ilifridos that will present about the schematic and the equation. So we move on to the equation. So the equation that we created for our project are as shown in this slide. So as you can see, the numbers of transistors that came out from the equation is 12 transistors. So 4 transistors for inverter at output and Q bar, and the rest of transistor is for input P, Q, R, and S. Okay, so we move on to the schematic. For the schematic diagram, you can see the inverter that we create at the output. It is because the output we don't put any full bar on the top of it. So we will move on to the test bands. So the test band is the step before we create the waveform of the schematic. So the test band, we use the pulse because it is easy to create rather than PWL. Okay, so the waveform that we came out from the test band is same as the truth table that we create from the equation. For example, the input PQRS is 1, it will be the output will become 1. And if the input PQRS is 0, the output will be 0. And if the input PQRS is 0011, it will become 1. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rosmaidi Miroslan. Now I will continue for the next part. This part is about our mini project layout and the process to make the layout. Okay, first step, to make a layout, we need to have a complete circuit. After we have complete circuit, we need to declare what yellow path we want to use. Before that, our circuit have 4 input, which is P, Q bar, R, and S. So my team declared to use a yellow path, which is P, Q bar, S, and R. As you can see in the green arrow, represent our yellow path. When we have a yellow path, so we can go to the next step, which is to build a state diagram. Next, this is our state diagram for our new project. State diagram is the last step for we to make a layout. Why we need to have a state diagram? Because the state diagram is a basic design of the layout. When we have state diagram, it will make the process to make a layout become easier. In state diagram, it have a few color that used, with light, blue, green, red, pink, black, yellow, and also orange. Blue represent to metal 1, green represent to active area, red represent to polysilicon, pink represent to metal 2, black represent to contact, yellow represent to well, and the last one, orange, represent to declaration line. After we finish design the state diagram, we can start to design the layout. This is our layout. In this layout, we use 12 transistors. After that, we also use 2 inverters in this layout, one for Q bar and another one for the output. In this layout, we'll also need to use metal 2 because they have the connection overlap between each other, so we declare to use the method tool. Lastly, our final output for this layout is P plus Q bar times R plus S.
Good morning to all lecturers. My name is Mugilan Kijanaka Rajan. Today I'm going to explain our DRC and LVS. This is our DRC picture. Design rule checking or DRC is an area of electronic design automation that determines whenever the physical layout of a particular chip layout satisfies a series of recommended parameters called design rules. For our layout, we got three DRC errors. There are few ways to solve this error. Firstly, for the red color, we need to solve the spacing. We need to move poly contact to upward. After that, we need to check the size. And finally, we got no errors. Okay. The layout of schematic LVS is the class of electronic design automation EDA verification software that determines whenever a particular integrated circuit layout correspond to the original schematic or circuit diagram of the design. At first, we got 9 errors for LVS. This diagram show all the 9 errors. All these errors is due to poor connection and missing gate. After we solve the connection and missing gates, we are able to get no errors. As conclusion, we are able to finish the project in the time given. We also able to solve all the errors. This is our final layout after finished. We also want to thank our lecturer for guiding and help us to finish this project. Thank you.